In this video, we will solve some questions from laws of motion. The first question is a body of mass m equal to 3.513 kilogram is moving along the x-axis with the speed of 5.00 meter per second. The magnitude of momentum is recorded as. So four options are given. So you can see the four options are very close to each other. Okay, so we have to find the most correct one, most close one, or most appropriate one. Okay, so the given value is mass 3.513 kilogram and its velocity, that is 5.00 meter per second. Okay, so we have to find the momentum. Okay, just magnitude is enough, so we don't have to consider the direction of the velocity or direction of motion. Okay, so the formula for momentum is P equal to mass into velocity. So mass value is 3.513 and velocity is 5.00. So if you multiply these two values, you will get 17.565. Okay, so before that you have to check the number of significant figures in the mass and velocity. So the mass contains 4 significant figures. Okay, the velocity term contain 3 significant figures. So zeros after the decimal point are significant. Okay, it contains 3. So the least of these two is 3. Okay, the first one contain 4 significant figure and second one contain 3 significant figure. The least of these two is 3. So the answer should contain only 3 significant figures. So we have to round off this value. Okay, so before rounding off this, we have to remove the last term. Okay, so how do you remove the last term? 1, 2 and 3. Okay, you have to cut this. So the answer is 17.5. okay, so you have to check the cutoff digit. After this, you have to check the cutoff digit. Here the digit after the cutoff digit is greater than 5. So whenever the digit is greater than 5, you have to add the plus 1 to the previous number. So this 5 becomes 6. So the answer is 17.6 kilogram meter per second, option B. Okay, so now this answer contain only 3 significant figures. Okay, next question is a player caught a cricket ball of mass 150 gram moves at a rate of 20 meter per second. Okay, so if the catching process is completed in 0.1 second, the force exerted by the ball on the hand of the player is equal to. So four options are given: 300 Newton, 150 Newton, 3 Newton and 30 Newton. Okay, so initially a ball is moving at a speed of 20 meter per second and a player catches it. At the moment he catches, the velocity of the ball becomes 0. Okay, so this speed reduction from 20 meter per second to 0 meter per second, this reduction in speed happens in 0.1 second. So we have to find the amount of force exerted by the ball in the hand of the player. Okay, on the hand of the player. So let me explain this question again. So a ball is moving at a speed of 20 meter per second. So a player catches it. So at the moment he catches, its velocity reduces to 0 meter per second. This speed reduction takes only a 0.1 second. So with this data, we have to compute the amount of force exerted by the ball on the hand glove of the player. Okay, so the first, note down the given values. Mass is given. Mass of the ball is 150 gram. Before doing the problem, we have to convert this into kilogram. So gram to kilogram conversion takes with divide by 1000. Okay, 1000 kilogram. So if you want to convert the gram into kilogram, you have to divide the value with 1000. Okay, the next one, initial velocity of ball is given. As usual, we take that as 20 meter per second and the V denotes the final velocity, that is 0 meter per second, and the time taken for this entire process is 0.1 second. Now we have to find the force value. From the second law of motion, we can write the F equal to m into v minus u by t. Okay, this indicates the F equal to m into v minus u by t. Okay, so here the v minus u represents the acceleration, so you will get the second law as F equal to ma. Okay, just substitute the value 150 by 1000, its mass value, and v value is 0 and u value is 20 and the time was 0.1 second. Okay, so 0.1 into 1000, it becomes 0.1 into 1000 is 100, and 150, 0 minus 20 is minus 20. Now you can cancel 2 zeros with the 2 zeros, so you will end up with minus 2 into 15, that is nothing but minus 30 Newton. So in this case you can just ignore the sign, so the answer is 30 Newton. Okay, so first we have to note down the given data and write the value, write the formula and substitute the value. Mass value is 150 by 1000 and v value is 0, u value is 20, this minus is in the formula itself, and the time value is 0.1. now you can cancel 10 for the 0.1, you will get only 100. Okay, then you can cancel the 0 of 20 and 10 with the 150. Okay, at the end you will get minus 2 into 15, so you will get the force value of minus 30 Newton. This negative value indicates that the force is acting on the opposite direction of the direction of motion of ball. Okay, actually this force suppresses the velocity of the moving ball, so it is taken as negative, so we got the negative value. But in the option all the values are positive, so you can just consider the magnitude alone, we don't have to consider the direction. So question number 3, a particle of mass 0.3 kilogram is subjected to a force F equal to minus kx with k equal to 15 Newton meter. So what will be its initial acceleration if it is released from a point 20 centimeter away from the origin? Okay, a force equation is given, F equal to minus kx, a force relation is given, F equal to minus k times x, and the mass of the particle is also given, that is 0.3 kilogram, and the value of k in this equation is k equal to 15 Newton per meter. So all these values are in the question itself. Okay, now this mass is released 20 centimeter from the origin, so the direction from the origin is not mentioned, whether it is positive or negative. Okay, so I am assuming this value is positive. Okay, if you get the answer as negative value, so we can say that our assumption is wrong. Okay, so initially we assume the value of x is positive and this is positive. Okay, now substitute the value, first find the value of force value. Okay, F equal to minus, the value of k is 15, I am just using it here, and the displacement from the origin 20 centimeter. So if you convert this into meter, you will get 0.2. okay, so 20 centimeter is equal to 0.2 meter. Just replace the value of x in this, so you will get minus 3 Newton. So you are getting the force value is negative. Now you have to find the acceleration. So the formula for acceleration is F equal to m into a. Just find the value of a from this, take this m to the left side, so you will get F by m equal to a, and the value of F is minus 3 and mass value is 0.3. so if you divide these two, you will get minus 10 meter per second square. Okay, so this force is acting in opposite direction to the direction of motion of particle. So just take the numerical value alone, ignore the sign. So the answer is meter per second square. Okay, next question, two masses m1 5 kilogram and m2 4.8 kilogram, okay, are tied to a string which is hanging over a smooth pulley. So this diagram is given in the question itself. Two masses are there, m1 this is 5 kilogram and m2 4.8 kilogram. These two are tied to the two ends of a string which passes over a smooth frictionless pulley. Okay, whenever they are given the whenever the word smooth is given, we have to ignore the friction. Okay. Now, what is the acceleration of the masses if the masses are free to move? If these two masses are released from their state, so it must move. Okay. So we have to find the acceleration of that motion. Okay. So we have to take the value of g as 9.8. So first draw the free body diagram of mass 1. So it will be like this. Mass 1 itself, it will act m1 into g. Okay. So this is 5 kilogram and mass 2 is 4.8 kilogram. So if this setup is freely released, this 5 kilogram will move towards downward and 4 kilogram move towards the upside. Okay. So the inertial resistance acts in the opposite direction of motion. So the inertia of this mass tries to prevent the motion of mass 1. So it acts in the opposite direction. The formula for inertial motion is m1 into a, and there is a string, you have the value of tension T. Okay. So for next mass m2, this is m2, the same thing, gravitational force always acts in the downward direction, but the second mass is moving in upward direction. The resistance to the motion, the inertia will act in the downward direction. That is nothing but m2 times of a, second mass into under its acceleration, and the string is tied to this end, so it has the tension value that always acts in the direction away from the body. Okay. So tension always acts in the direction opposite to the body. Okay, or away from the body. Okay. So two diagrams we have drawn. Now we have to identify the what are all the forces which supports the motion. If you take the first mass, it moves in downward direction, so the mass m1 supports the motion. Okay, the first mass is moving in downward direction, so all the downward forces, downward directed forces are supporting the motion of mass 1. So the mass m1g supports the motion, but the tension opposes the motion, it acts in opposite direction, and inertia, that is also acting in opposite direction. So T plus m1a. Now consider the second mass. In the second mass also, the second mass moves in upward direction. Okay, so all the forces from the second mass which are all acting in upward direction supports the motion of mass 2. Okay, so T, the value of T tension supports the motion, so we have to write that on left side. But m2 and m2g acts in downward direction, but the mass is moving in upward direction, so these two are taken in the right hand side. Okay, m2a plus m2g. Okay, so let me explain this equation again. So the first, the mass 1 moves in downward direction. Okay, so we have to identify the what are all the forces which supports the mass 1. So self weight of the mass 1 m into g, so this one supports its motion. Okay, so I have written it on the left side. So if you consider the tension T and m1a, these two are acting in the upward direction, but the mass is moving in downward direction, so these two are actually opposing the motion of mass m1. So we have to write this on the right hand side. Okay, now check the mass 2, second mass. This second mass is moving in upward direction. Okay, second mass is moving in upward direction, so the only force supports its motion is tension, so I have written on the left side, and the remaining two forces are opposing the motion of second mass, because these two are acting in downward direction, and but the mass is actually moving in upward direction, so these two should be written on the right side. So in the right hand side we have the four set of forces. All these four forces are opposing the motion of the system. Okay, in the left hand side you can see only two forces are there, these two supports the motion of the system. Okay, now you can cancel the tension on both sides. Okay, now you can take the value of a as common in this side. m1g equal to a is common on these two terms, let's take that out. You will get m1 plus mg plus m2 into g. Now take this m2g to the right side, or left side, you will get m1g, here it is positive, so it will become negative. m2g equal to a times of m1 plus m2, this is m2. Okay, now you can take the g on this term, you will get g times of m1 minus m2 equal to a times of m1 plus m2. Okay, now substitute the value of g. We have to take the value of g as 9.8. It is given in the question. So 9.8 into value of m1 is 5, m2 is 4.8 equal to, and value of a we have to find, and m1 value is again 5 and m2 value is 4.8. Now you can do the basic value. So 5 minus 4.8 is 0.2 equal to a. 5 plus 4.8 is 9.8. Now you have the 9.8 on both sides. You can cancel these two. So you will find the value of a is 0.2 meter per second square. So this is our answer. So the first thing, the first important thing is you have to draw the diagram correctly. Okay, and the next thing is you have to identify the what are all the forces which supports the motion and what are all the forces which oppose the motion. So let's group them in the two sides of the equation, then you can find the unknown value. Okay, so a particle of mass m is moving in a straight line with the momentum p. Okay, a particle, we can take this as the particle, its mass is m. Okay, it is moving in a straight line, so its initial momentum is p. Okay, when the time is 0, the value of time is 0. When the time is 0, a particle is moving in a straight line, its initial momentum is p. Then a force F equal to kt acts on it in the same direction. Okay, so at this time a force F is acting on it. Okay, so its value is given as F equal to k times t. So this force is acting along the direction of motion. So what will happen if a force is acting on a moving particle along its direction of motion? The velocity of the particle will increase. Now its momentum is increased to 3p. Okay, so because of this force, the momentum of this particle changed to from p to 3p. So this force is acting for a period of t seconds. Okay, t interval of time. Now the time is, at the time value is 3, capital T. This is capital T. Okay, so at the moment its velocity, its momentum becomes 3p, the time value becomes t. Okay, initially a particle of mass m is moving with the momentum p in a straight line, so a force is acting on it at the time t equal to 0. So after some time t, its momentum changes to 3 times p. Okay, 3p. Now we have to find the time interval value. So 4 options are given. So in this case k is constant, we have to find the value of t. Okay, so let's write the force equation. So we have F equal to k times t. So we know that from the second law of motion, force is nothing but rate of change of momentum. Okay, force is nothing but rate of change of momentum. So let's use this equation here. We will get kt equal to d times of p divided by dt. Okay, so I'm equating this value in this one. Okay, with this one. So the value of force is kt, and the value of, and the formula for force is rate of change of momentum. Okay, so I'm just substituting the value of f in this equation. I will get this form. Okay, now here the force is given in the function of time. Okay, so I am taking this t terms to the one side, the terms which contains t to the one side. Okay, so we will get kt dot dt equal to dp. Okay, this dt is in division. If it goes to the left side, it will be it converted into multiplication. Okay, now you have to integrate it on both sides. Okay, just do the integration, kt dt, and this is dp. Now the lower limit in this case is time t equal to 0 and the time value t equal to capital T, because this entire process happens for the from time t equal to 0 to and the time value t. Okay, so in this case momentum is the variable, so we have to use the initial value of momentum is p and final value of momentum is 3p. Okay, so in the left hand side time is the variable, so we have considered the initial value of time and final value of time. In the right hand side we have the momentum value, so we have to consider the initial momentum and final momentum. Here the k is constant, we can take this outside, so we will get k times of integration of t into dt is t square by 2. Okay, this is t square by 2. Okay, the general form of integration is integration of x power n times of dx. Its general form is x power n plus 1 divided by n plus 1. So in this case you have the t instead of n. Okay, the value of, you can compare these two. If you compare these two, the value in the power of t is 1, so t plus 1 is, sorry, 1 plus 1 is 2 and the 1 plus 1 is again 2. So just replace the value, you will get t square by 2. Okay, now on the left hand side, so write the limit also. So integration of dx becomes x, so integration of dp becomes p. So generally if you have the only one variable without any equation, we have to write the term alone. Okay, only you will have the term alone. So do the same thing here, you have the only the variable here, so just write the variable p and the lower limit is p, upper limit is 3p. Now substitute the limit value, replace the value, you will get k times of, instead of small t you have to use the capital T, you will get t square by 2 minus 0 square by 2. Okay, first you have to substitute the upper limit, then put a negative sign and substitute the lower limit. Similarly, first you have to replace the p with 3p, upper limit value is 3p and lower limit value is p. Okay, now k times of t square by 2 and this term becomes 0. Okay, 0 by anything is 0 and 3p minus p is 2p. Okay, now take this 2 to this side, you will get k t square equal to 2p into 2, so this becomes 4p. 2 into 2 is 4 and p comes here. Okay, so kt square equal to 4p. Find the value of t from this one, you will get t square equal to 4p by k. Okay, t square equal to 4p by k. So I hope you can see this, so I'm writing this again here. Okay, so t square equal to 4 times p by k. So here the k is in multiplication, if it goes to the right hand side it goes to the denominator of 4p. Okay, now we have to find the value of t, we have the t square, so I am taking this square to the left side, so right side it will become square root, so t equal to root of 4p by k. Now you can take the 4 from the root, so you will get 2 times of p by k. Okay, you will get 2 times of root of p by k. So the answer is option A. So whenever you have the force as the function of time, so somehow it will involve the integration. Okay, and also you cannot find the direct value from this, there is no numerical value. In this case the force is also not constant. Okay, so whenever you don't have the constant force, you have to go by the integration method. Okay, and also the terms in the all the options contains square root, so we cannot get the square root until we use the integration. Just also remember this.